Again, it's a red stick.
What is going on, guys? Welcome back to C++ tutorial series. In today's video we're going to talk about functions, so let us get right into it. Alright, so functions are essentially just blocks of reusable code, and we already know such a function, which is the main function. It's written like int main parentheses, curly brackets, and a return statement. And we've talked a little bit about that, but now let's get let's get into more detail here. So the first thing that we do is we specify a return value data type. In this case, it's integer, and this return value data type is the data type that we demand from the return statement. So in this case, we return 0. 0 is an integer. The return value type of the function is integer, so that's okay. And essentially what this means is that, let's say I have another function down here called add, for example. It's also of the data type int. And I have parameters in here. Or actually, let's for now just not use any parameters at all. Let's just say I have a return value 10, for example. Now, if I call add in main, and it would not work in that constellation, we're going to talk about that in a second, but let's say the function add exists and I call it in main. What happens is that as soon as I call add here, I jump into that block of code, execute the code lines here. Of course, I can have multiple code lines with statements. And then what happens is once I'm done, I reach the return statement, which means that I return to the point where this function was called, in this case, this point here, with the value 10. With the value 10 meaning that I can get the value and store it or process it, which means that I can go ahead and say int, x equals add. This is important because return means that I can always get a value from it. So again, we call the function, we get inside of it, we execute the function code, we return to the point where the function was called with the value that we return. And this value has to have the data type that is specified here. This is how functions basically work. And we can actually go ahead and implement a real add function here. We're going to specify two parameters. So inside of these parentheses here, we can specify parameters that are going to be processed by the function. I mean, they don't have to be processed by the function, but usually when you pass something, you don't want to pass it uselessly. So we're going to say int x and int y. Now, those are not actual variables. Those are just definitions. We say, okay, this function takes on an integer, which we're going to refer to as x, and an integer that we're going to refer to as y. And then inside of that function, inside of the function scope here, we can work with x and y. In this case, the only thing we want to do is we want to return the sum of those, so x plus y. This is all we want to do. And this function right here, what it does is it takes integer x, integer y, it just adds them, and then when we return it, we jump back to the point where this function was called, and we return the result. In this case, just the sum of the two parameters. Now, we're not going to see that working here because even though Visual Studio Code is going to show us that this function exists and we can actually call it, we're not going to be able to do it, and I'm going to tell you why in a second. But first of all, let me show you. std cout at 10 and 20, for example, std end line. So if I run this right now, you're going to see that we get error. Add was not declared in scope, in this scope essentially. This is because in C++, in order to be able to access a function, you need to have already declared it above it. So we're going top down here. We're going, if a function is defined here, like the int function, the int main function, not the int function, the int main function, we know that this function exists down here, but we don't know that the function that is defined down here exists here. We don't know it here. So what we can do to fix it is we can just go ahead and put the function above the main function, then it's going to work. Because first we define it, then we use it. Obviously, that's the logical order. But this is not necessarily a good practice. I mean, you can do it, but sometimes it's not a good practice. And usually what we do is we define the main function first, and the implementation of the other functions comes below that main function if it's in the same file at all. But that's not the only problem. It's also a problem when we have, for some reason, other functions here. So let's say I have a function f1 that does something, I don't know, return 0 in this case. I'm just going to to do some sample functions here. It doesn't matter what these functions are doing, but let's say somewhere inside of that function, f1 needs to access in some if statement, in some loop, somewhere in here, we need to call f2. But at the same time, in some if statement, in some loop, in some corner of that function f2, we also need to call f1. So what do we do? Do we define f1 first? Do we define f2 first? Because obviously f1 refers to f2 and f2 refers to f1. So we cannot have both functions above the other one. Or can we? Because that's actually what we need to do here in order to have that happen. What we can do, or what we usually do in C++, is we go ahead and define the functions up here, but we implement them down below. So what we do essentially is we say there is a function with the return type int that is called add and takes 2 integers as a parameter. We don't need to specify x and y here. We can do it. It's not wrong. But it's enough to just specify that we have 2 integers. Now this is the function signature. This is called the function signature. We have the return value, the name, and the parameter data types. And also the amount of, obviously. By doing that, we tell the whole program here that there is such a function, so you can use it, but it's going to be defined later on. Because of that, the main function now knows that the add function exists. It knows that it can pass 2 integers, and it's going to get an integer so it can use it without giving us an error at compile time. But at the same time, we also have the implementation down here. So I can go ahead and run this. And you're going to see that it still works, even though add, the functionality of add, is defined below the main function. And I'm not going to do this really here. I'm not going to implement it actually here because obviously if I just make function 1 calling function 2 calling function 1 and so on, it's going to never stop, or it's going to just do nothing. But essentially, if you have a reasonable or 2 reasonable functions that call each other in some cases, this is going to be necessary, and you can just go ahead and say int f1, int f2. So you're just defining that those functions exist, and that's it. And then down here, you define what they're doing actually. Now, actually, we don't need to always return an integer, even though we did it up until now. We can also return a float, a boolean. For example, I don't know, let's say we have a function boolean is greater than. We can do it like that. We can say is greater than, and then we pass a number x and a number y, and we return if the number x is greater than the number y. So we can go ahead and say std cout is greater than 10.5. We should get a 1 here. And of course I need to define that that function exists. So bool is greater than, that takes 2 integers. And we can go ahead and run this now. I can see I get a 1, which stands for true. What we can also do is we don't have to actually return any data type at all. Right now we are returning integers, booleans. We can do it with float. But sometimes we just don't want to return anything at all. And you don't have to return something in C++. Actually, it allows you to define an integer function here and not have any return statement, or just return nothing. But it's not something that you should do. So what you should do is, if you have a return value type, you should actually return something. If you don't have one, or if you don't want to have one, you can go ahead and define a void function. And this void function is, void means empty or nothingness or whatever. And void essentially says that you don't have any return value at all. And you can do it like that. You can say my function, for example, void my function. And you're going to just do something in here like print hello world, like that. So this does something, but it doesn't return something. And because of that, we can just call it my function void my function. And if we run this, we can see it gives us hello world. Now, of course, the return value of that function is non-existent. So we can go ahead and say std cout what this function returns. And it's not going to return anything, actually. It's going to return the void, nothingness, which essentially gives us an exception. I did not know that we're going to get an exception here. But all in all, when you have a void function, you don't want to have a return value anyway, so you're not going to return anything using a void function. Now, one thing that at least we learned in university that is best practice or done or you should be doing is when you have 0 parameters, when you don't have any parameters, you should not just not have any parameters, but you should pass a void keyword in here. I'm not sure if this is really something that is done amongst professionals. We did it in university, that's why I'm showing it to you, but take it with a grain of salt. I'm not sure if this is a best practice actually, but you can just go ahead and type void in here to make clear there are no parameters for those functions. So we do it like that. Down here, you can do it as well. This essentially has the same effect as not passing any parameters at all. It just means emptiness. We don't have any parameters. It's maybe just an additional safety to say nothing is going to be in those parentheses. All right, so now we're going to talk about something called overloading functions or function overloading. And the basic idea is that we have a function like int add here that takes 2 integers as a parameter and has this signature int add with 2 parameters int. And maybe you want to have another function called int add that takes 3 integers. Now, this is possible in C++ and it's called function overloading because essentially you're using the same name. I think this is not possible in Python as far as I know. I'm pretty sure it's not possible in Python. You cannot define the same function signature or not the same function signature, the same function name with a different function signature and have it be a different function. So in this case, we have int xy, which returns x plus y. And here we can say x plus y plus z. But in this case, we're also going to print something just to see that it's a totally different function here. We're going to say using 3 parameters, std, and line, like that. And of course, we need to define the header or the signature up here. Int. And then we can go ahead and print how we also add 30 to it. And by doing that, we call a different function. We call the function this function here and not this function here with just more parameters, because this is not, we're not talking about functions with a variable amount of parameters yet. We're just talking about a fixed size of parameters or a fixed function signature, but we have the same function name for different signatures. For example, we could also have a string add function. I don't know if we have some idea of how to process that, or if we want to do something with that. In this case, you can see it's calling using 3 parameters because we're calling this function here. We're not calling this function with just more parameters. And we can also go ahead and say int, or actually, sorry, string std string add std string s1 std string s2. And we can return just on a concatenated version. I'm not sure if it's done like that or if it's possible like that, but I think it is actually. So by doing that, of course, we need to say std string add std string, which is a class, by the way. This is not a primitive data type. We're going to talk about object-oriented programming in a future video. But for now, we're just going to print the result of hello and world. Let's see what happens, if it works or not. Yeah, as you can see, it works. And this is, again, another function signature. One thing that I'm not sure about, to be honest, is if we can have the same, or actually I think it's not possible, but let's find out. If I have the same return value, actually a different return value. For example, I'm returning a string here, but I have the same parameter signature, so int, for example. I think this should not be possible because when I'm calling it, I don't know what it should be doing right now. We don't know, should it be returning a string or should it be returning an integer? So my guess is, I'm not sure, we're going to find out now. I'm not sure if it's going to actually be possible to compile that, but we're going to do it. Or we're going to try it. We just need to return a string. And we're going to say, I don't know, this is just a test. So we're going to return test. But I think we should get an error here. Yeah, as you can see, unused, or actually this is a warning. Where's the error? Ambiguating new declaration of that. Yeah, as you can see, it's confusing because when we call add on two integers, what should it do? Should it return a string or an integer? So it doesn't work like that. In order to overload functions, what you need to do is you need to change this part. This part needs to be different. You either want to have a different name or a different set of parameters. So this is how you overload functions in C++. Now, one thing that I also want to talk about is default values for parameters. Let's say we have something like the add function here with 3 parameters. And what we want to do is we want to have a default value for z, for example. So if someone does not pass the value for z, or actually then it's going to be that. So let's, or actually this, so let's comment that out. Let's say we don't have that function here. We don't have it, doesn't exist. We just have it with 3 parameters here, but we want to have the option of just passing 2 and the third one being chosen automatically if it's not passed. So what we can do here is we can just go ahead in the function signature up here and say the third int equals to 90, for example, like that. So you can see int add int, and the last int is equal to 90. So in this case, what we get here, since we don't have the function with 2 parameters anymore, it does not exist anymore, we're calling the function with 3 parameters, but since we're not passing a third one, it's going to assume that it's just 90. And in this case, we're passing one, so it's going to assume it's 30. So you can think about this. 10 plus 20 is 30, plus 90 is 120. In this case, we're going to get 120, and in the third one, in the second function here, in the second function call here, we're going to get 60 because it's 10 plus 20 plus 30. So let's see what happens. And you can see 120 and 60. And if we don't do this here, this function call would not even be possible. So we can see that we run into an error because there is no matching function to add int because we commented out. It doesn't exist anymore. I mean, actually, this function, technically speaking, exists, but we define it down here. So it does not really exist for the main function. But as you can see, this is how you define default parameters. And you can not only define it for one, you can define it for multiple parameters at once. So you can say, okay, if I don't pass anything, this is 90. And if I don't pass anything for the second one, it's going to be 50. And then, you know, if you pass something, it just takes the values you passed. But if you don't pass anything, we can also just go ahead and say add 10. And then we're going to get 50 plus 90 plus 10 is 150. So in this case, we should get 150, as you can see. Now, one thing that you need to notice here is that you have to do it from right to left. So if you want to have a default value for this one, for the second parameter, you also need to have one for the third parameter. You cannot do it like that. You cannot say the first parameter has no default value, the second one has one, and the third one doesn't have one again. This does not work. I think it should not be even able to compile. As you can see, default argument missing for parameter 3. It doesn't work like that. And of course it makes sense because how do you want to determine what you passed and what you didn't pass? If I pass 2 parameters, did I pass one for the second one? Did I pass one for the third one? How did I do it? So if you want to have default parameters, you need to start from right to left. And if, you know, for example, this is a different parameter, if you're choosing names for that, or if you have a certain order, and you definitely want to have this as a default value, you should just replace it and put it in the end here if it's a different data type or a certain specific parameter that you want to have a default value for. But this is how you define default values in C++ for functions. All right, so last but not least, we're going to talk about something that's going to be very interesting for those who are actually interested in what's happening behind the scenes and are actually interested in some of the memory management involved in C++. Because we talked about storage classes already, and we mentioned the storage class static. And we said that if a variable is defined static, it means that essentially when you enter the scope where this variable is defined or this value is defined, you're allocating memory and you're not freeing that memory until the program is terminated. So let's say we have a function, I don't know, let's just have it a void function, my function, and this function has a certain scope. Inside of that function, we have certain things that are only visible inside that function. Of course, if I define an integer x here equals 10, I'm not able to access that integer in the main function. So it's only valid inside of that scope. And what C++ usually does, or what the compiler usually does, or what we do at runtime, is we enter that function code. So for example, if I call it in the main function here, I call this function, I enter the function code, I allocate memory for x, and then I do something with x. I don't know, I print it, I calculate something with it, whatever. And then we get out of the function either with the return statement or just because we reach the end of the function. And then we go back here, we free the memory for x, and next time, you know, we can do something here, and next time I enter my function, again, we allocate x again, we do something with x again, we free x again. And we said that by specifying the keyword static here, we don't do all of that. We allocate once, so the first time I enter my function, we allocate x, or we allocate the memory for x, and then we don't free that memory until we terminate the program. So why is that even important? What does that even mean? What are the effects of this? And we're going to show, or I'm going to show to you what the effects are. Let's say we're not using static here, and all we're doing is we are having a value x that we initialize at 0, let's say, and then what we do is we just say x++, so we increase x by 1, and then we just print the value of x. Let's say that's all the function does. It creates a variable, sets it to 0, increases it by 1, and prints x. Now, obviously, all this function is ever going to do is it's going to print 1. All the time it's going to print 1 over and over again, no matter how many times we call that function, because what it's doing is it's creating 0, increasing it by 1, and then printing that value. It's not too complicated. Now, this changes when we just add the keyword static here. And it changes because x is not freed anymore. So if I go ahead and say run here, you're going to see that we get 1, 2, 3, 4, 5, 6. This is because the first time we initialize x as 0, but then we cannot initialize it again. It already exists. The memory is not freed. It's already allocated. So this line of code here is not even important anymore because we see it's static, it's already there, so we don't have to allocate it again. We can just use it. So next time we increase it by 1, we increase it by 1 all the time, but the value is never reset to 0 because we don't initialize this this variable again. We don't have to allocate the memory again. We don't have to go through the initialization process anymore because this value is static once, or this variable is static once it's allocated. It stays allocated until it's freed manually or by terminating the program. So in this case, we get a result 1, 2, 3, 4, 5, 6. Alright, so that's it for this video. Hope you enjoyed it. Hope you learned something. If so, let me know by hitting the like button and leaving a comment in the comment section down below. I tried to make this explanation today a little bit more technical because I want you to really understand what's happening behind the scenes with stuff like the static keyword here, because that's really important. It makes you a better C++ programmer, but it also makes you a better programmer in general, because even if you're coding in Python and you don't have to deal with that, sometimes if you're going to more advanced fields, you maybe are going to realize that stuff doesn't work as easily as you thought it should work. And this is because something on a lower level is not working the way you expect it to work. And then you can actually understand what's happening on a lower level. And this is very valuable knowledge, I think. So if you like it, let me know by hitting the like button. Also, make sure you subscribe to this channel and you hit the notification bell to not miss a single future video for free. Other than that, thank you very much for watching. See you next video, and